Okay, let's look how to convert empirical into molecular formulas. To do these questions, you have to first find the empirical formula, then you absolutely need the molar mass to determine the molecular formula. You can't do it without having the molar mass in the problem. Okay? You need the molar mass in the problem. Just one more time. Okay, let's look at an example. So succinic acid is a substance produced by lichens. It is composed of 40.68% carbon, 5.08% hydrogen, and 50.24% oxygen, has a molar mass of 118.1 grams per mole. What is the molecular formula? Should be a question mark. Okay. So this is the molar mass. We use it right at the end. Okay? So we're going to follow our steps like I did last video, 1 through 5 or whatever I gave you. So the step 1 was that we were going to convert a little percent sign to grams, right? So we have 40.68 grams of copper, 5.08 grams of hydrogen, and 50.24 grams of oxygen. Okay? Everybody can do that part. Let's go to the next step. So just note that I copied the problem down wrong. It should read 54.24 grams of oxygen, not 50.24. All right, so I set up my calculations to turn my grams into mole. So 40.68 divided by 12 in my calculator gives me 3.39 moles of carbon. Okay, 5.08 divided by 1.01 grams gives me 5.02 moles of H. And last but not least, oxygen. I take 54.24 grams divided by 16 on my calculator, and I get 3.39 moles of oxygen. Okay, the next step was then find the lowest number and then divide by the lowest number of moles. So if I look, the lowest number is for both. So I'm going to divide everybody by 3.39. I'm going to do that on the next slide. Okay, so for carbon, it's going to be 3.39 divided by 3.39, and I'm going to get 1. Hydrogen, I'm going to take 5.02, and I'm going to divide it by 3.39, and I get a decimal 1.5. And I take oxygen, and I get 3.39 divided by 3.39, and I'm going to get that equal to 1. So my three subscripts are 1, 1.5, and 1. Okay, so I'm going to write that out now. Okay, C would go first, then my H, and then my O. Okay, so I'm just going to put that in a different color. Just give me a second here. So I have a 1, a 1.5, and a 1. Have you ever seen a formula that has a decimal place for a subscript? Okay. Please answer no. Okay, so no, you haven't. So we have to do something to this subscript to make sure that it isn't a decimal, that it's a whole number. The easiest thing is to multiply it by the whole empirical formula to get up to a whole number. So if I multiply this, obviously, by 2, 1.5 times 2 is 3. So my actual empirical formula is C2H3O2. So on a side note here, if I had a 1.3, for example, I'd multiply the whole thing by 3 to get rid of the 0.3, etc. Right? So just play around with this number that you're multiplying by, so make sure that everybody is a beautiful whole number when writing out the empirical formula. So this is my empirical formula. So C2H3O2 is my empirical formula. Okay, and that's where we kind of ended off last video. Okay, so how do I turn this into a molecular formula? Well, the hint should be in the question, right? In the original question, it gave me the molecular formula's mass, right? So 118.02 gram per mole is the formula mass, 0.1, holy, okay, 0.1 grams is the molar mass for succinic acid, right? So I need to find a ratio relationship between my molar mass, or molecular mass, and then I need to divide it by my empirical mass. And I'm going to get a whole number, okay? So what's the ratio or relationship between my molar mass, my molecular mass, or my molar mass, and my empirical mass? So I already know the molecular mass, right? 118.1. But what is the empirical mass? So what is the mass of C2H3O2? Okay, so what is its molar mass? You can easily find that out. I've seen all of you do it. You're really good at doing it. There's 2 C's, there's 3 H's, and there's 2 oxygens. I'm just going to speed this part up. You're going to add them all together, do the math, la la la, and you're going to get something like 59.03 grams. Okay, so things are going to be different if you use different rounding, right? Okay, but you're going to get a value roughly. And this is the molar mass of your empirical formula. Okay. Now you're going to divide the 118 by the 59.03. Okay? So you're going to take the 118.1 grams per mole, and you're going to divide it by the empirical mass, which is 59.03 grams, and you're going to get a 2. Okay? That means, this 2 means that we're going to multiply every subscript in the empirical formula by 2 to get the molecular formula. Okay? So I'm going to write out the empirical formula again, C2H3O2, and now I'm going to multiply every subscript by 2 to get C4H6O4. And that is the molecular formula for succinic acid. Okay, so just a quick note for this. You need the molar mass of the molecular formula to do these questions. Okay, you can't do it without the molar mass. Okay, and then you also have to create a ratio by dividing the molar mass in the question that you're given, the molecular formula mass in the question. You have to divide it by the empirical formula mass to get it that ratio, and then you're going to use that to multiply it by your empirical formula. And that's pretty much it. I hope this helps.